You know, when you hear the word average, you probably think, okay, I get it. I know the whole story. But what if I told you the average is often the least interesting part of the data? Today, we're going to look beyond that to find the hidden story using something called measures of dispersion.
And to get our heads around this, let's start with a puzzle. Imagine a school is about to announce its valedictorian. It's come down to two final candidates, and the question is, who really deserves that title?
All right, so here they are. On the left, you've got student A, pretty solid grades all around. And on the right, there's student B. Now, they've got some really high scores, but also some lower ones. So you look at this, and it's not super obvious who's on top. What's the first thing we all do? We find the average, right? And here's where it gets interesting. Turns out they both have the exact same average grade, 93.20. So now what? The average doesn't help. It looks like a tie. But is it really? To find the real answer, we've got to dig a little deeper. Okay, so this is exactly where we have to start thinking beyond just the average. We need to look at the spread of the data. It's not just about the final score. It's about how they got there. And for that, we need a whole new set of tools.
And these tools, they're called measures of dispersion. And what's cool about them is they don't really care about the average itself. Nope, they care about how clustered or how scattered the data points are around that average. In other words, they're all about measuring consistency.
All right, let's start with the simplest tool in our new toolkit, the range. It's super quick, super easy, and gives you a first glance at how spread out the data is. Seriously, finding the range couldn't be easier. You just find the highest number in your set, find the lowest number, and subtract it. That's it. The number you get tells you the total span of your data.
Okay, let's take this back to our two students. For student A, their grades have a range of 6, but student B, their range is 12. Boom, that's our first real clue. Student B's performance is literally twice as varied. It tells us that student A is definitely the more consistent performer.
But, you know, the range has a pretty big flaw. Think about it. It only uses two data points, the absolute highest and the absolute lowest. It completely ignores everything in the middle. So to get the full picture, we need something more powerful, a tool that looks at every single grade. And that, my friends, brings us to the hero of our story, standard deviation. This is the one. This is the tool that's going to give us the full story and finally solve this valedictorian mystery for good. So what is it? Well, in simple terms, standard deviation basically tells you the typical distance of any data point from the average. So if you get a low standard deviation, it means all the numbers are kind of huddled together, close to the average. They're consistent. But a high standard deviation, that means the numbers are all spread out, much less consistent. Okay, I know what you're thinking. The calculation looks a little scary, right? But trust me, it's just a 5-step process. We're just gonna find the mean, see how far each number is from it, square those distances, do a little division, and then take a square root. Let's walk through it together. So to make this super clear, let's use a really simple set of numbers first, before we tackle the student grades. Let's work with these 5 numbers, 1, 2, 5, 7, and 8. Okay, step 1, find the mean, or the average. Easy enough, right? We just add them all up. That gives us 23. Then we divide by how many numbers there are, which is 5, so our mean is 4.6. Step 1, done. Step 2, now we calculate the deviation for each number. All this means is how far is each number from that mean of 4.6? And you can see the results right there in that second column. And here's a cool little trick. If you add up all those deviations, the sum will always be 0. It's a great way to double-check your work. All right, on to step 3. We're going to square each of those deviations. Now, why do we do this? Well, for 2 reasons. It gets rid of the negative signs, and it also gives a little more importance to the numbers that are really far from the average. Then we just add up all those squared numbers, and we get a total of... Okay, step 4. We take that sum we just got. Now, there's a little quirk here. Because this is just a sample of data, not the entire population, we don't divide by 5. We divide by n-1, so we divide by 4. This gives us a special number called the sample variance, which in our case is 9.30. We are so close now. And here it is, the final step, step 5. We just take the square root of that variance. The square root of 9.30 is 3.05.
And that number, 3.05, that is our standard deviation. It's telling us the typical distance any of our original numbers is from the average.
Okay, so now that we know how to do the math, let's get back to our students and finally solve this thing.
And wow, this table really says it all. Once we run the numbers for their grades, the real difference just jumps off the page. Student A has a standard deviation of 2.32, but student B, theirs is 4.96. That's more than double. The variation is huge.
And this is the key point, right? A lower standard deviation means lower variability. And that makes the average, that 93.20 we started with, a much, much more reliable indicator of how they actually perform. For student A, that 93.20 is a true reflection of their consistent, steady work. So there you have it. There's our answer. Student A with that tiny standard deviation is the clear winner. They're the more consistent, the more reliable performer, and they are our valedictorian. Mystery solved.
So what's the big takeaway from all this? It's that averages, on their own, can be really, really deceptive. It doesn't matter if you're looking at grades or investment returns or even sports stats. So often, the real story isn't in the average, it's in the spread. So from now on, the next time you see an average, please don't just stop there. Ask yourself, what's the spread? What's the standard deviation? Because I guarantee you, that's almost always where you're going to find the real story.